what you are seeing, another application where the traffic of the large scale telecommunications you can model as a graph, and these graph based teletraffic applications require to be solved on the AI actually. Then how do you really address these libraries? Also another issue which we need to know actually. So that means if you really see from the AI point of view, you have the attention transformer and you have the workloads, large number of small matrices. From application point of view, and also from computing point of view, are 8-bit, 16-bit computations. And from the uh, computing point of view, you have the single precision, double precision, and real complex. So many types of data is there, and how do you address all these things also very important actually. I quickly cover. Now, in the distributed computing point of view, how the distributed computing is basically going to be addressed in the AI. One is you have the TensorFlow and you have the PyTorch, and Horowitz is the another distributed computing deep learning framework that can be used to integrate the message passing as well as CPU, GPU, and that's what we do in the large scale distributed learning to make the training faster. What we discussed in the first half an hour, 40 minutes about the AI architecture challenges, memory wall, and then necessary conditions, everything. Later, we discuss about the 8-bit, 16-bit precision, and we also have the. We did not discuss more about the convolution neural network, deep neural networks, and attention and transformers. Now we are going to the distributed learning. How distributed AI is going to be addressed actually. If you really see in this particular picture, actually you have 4 missions are there, and each mission is having the large number of GPUs. Then you need to do the distributed training. Then how do we really work actually? Uh, so the other one here is that if you see in the distributed computing point of view, you have model parallelism or data parallelism. Srinivas, shall I take 5 minutes or 10 minutes, sir?
Sir, you can take 10 minutes, sir. 10 minutes, sir. 10 minutes. Yes.
Okay. Data or model parallelism. That means what? Now the AI memory wall, high performance computing, distributed deep learning, distributed machine learning, and distributed AI training. These are what the areas which we have to address in the thing. In that, HPCs come under the background actually. One is data parallelism, where the deep neural network doesn't fit into the device memory. Then how the training can be done actually? What are the issues? We also discuss about the uh, how we can do 8-bit, 16-bit computations on the GPUs, and how 8 GPU, 16 GPU, they can basically do GPU to GPU communication much faster using the NVIDIA annealing there. So now question is training part when we want to do on the uh, distributed computing system, then we need to think about what is the workload, how the transformer work on the every node, and then how many parameters are there, and how the hyperparameters can be tuned. All these things also very very important. Now in the GPU side, GPU memory bandwidth and number of GPUs, and we need to understand actually. And at the same time, we need to know about the accuracy also. Model parallelism is another one. You have the data parallelism, model parallelism actually. Model parallelism means you integrate all the systems with TensorFlow and message passing MPI, or you have the artificial neural networks and the message passing MPI and GPU integrate actually. All things we have to do. So the most important thing is that how the your distributed deep learning, that is basically artificial neural networks or the convolution neural networks or the at a higher level attention and transformer, how in distributed computing environment how do they really work, that is also very very important. And presently at this point of time, we have the good amount of open source software. We need to explore that one. Most importantly, when we do the computing during a training, one thing called each compute node will do many batch of large number of matrix operations. When they do large number of matrix operations, you use a mixed precision capability, that is 8-bit, 16-bit, 32-bit, 64-bit actually. So that means in the training you do more about the 16-bit, 32-bit, 64-bit. In the inference, you do only 8-bit, 16-bit actually. How do you address this thing? That means large number of group of matrix operations. How you can really launch an every node. That is also very very important in the case of distributed deep learning or distributed AI actually. So what are the frameworks are there today? Almost all the distributed computing system, you have the framework. All the framework like TensorFlow, Trion, Torch, Keras, MPI, everything is integrated. In NVIDIA GPU, everything is also completely integrated. We don't have to worry about the uh, programming APIs, everything. Completely high levels, one API which can address many of the applications. If you really see, if you do a computer vision application, MRI, CAT scan, medical operations, you do compute more memory. If you go to the teletraffic application, large amount of graph, large amount of telecom data is represented as a graph, huge amount of data you need to process actually. So there is a different kind of requirement from the application perspective. Then distributed AI, that is AI architecture, where the transformer, how the transformer work and how the attention transformer work, how the operations can be done. These are also very very important. So now, so model parallelism, if you really see the frameworks in the distributed computing point of view, one is you have CNTK, Triano, the PyTorch and PyGPU, PyCoda, and GPU array, and Cafe, TensorFlow. And below, if you have communication primitives, NCCL is the NVIDIA's, and then RPC protocols, message passing. Here, you have the CPU, GPU, TPUs actually. Every system is having any type of GPU, any type of TPU, even FPGA also there. Intel uses SQL programming environment. NVIDIA uses OpenACC and Coda programming integrated with MPI, and AMD uses OpenCL programming. These are the things. If you go a higher level, all the libraries, neural networks library on the GPU, and all the grouped large number of matrix operations, BLAS libraries, CU BLAS, and these are the way which the libraries have been also integrated. It's a single system image is available where a user can run the large scale distributed deep learning distributed AI application. The entire system consists of the compute nodes. Each compute node may have many GPUs also. So these are the program environment you require to handle. So my important question is how the architecture is going to address partitioning the data and distributing onto every processes. What is the scaling which we need to address? How much time it takes for the complete training? How many billion parameters exist in your transformer, everything? How the distributed learning will making very faster? That's what the challenge now. Now when we really implement, we don't have to write full code. We write only APIs. That's what you have mission 1, mission 2, mission 3 are there. Every mission is having, you can see 4 GPUs also there. Then how the machine learning framework work, that is what the TensorFlow across the missions, how the message passing MPA has been designed, and how the Keras and MPI has been integrated, how all-to-all communication happens, how GPU to GPU communication happens. All these things are basically combination of data and model parallelism for the coming under hybrid parallelism. So that means from AI architecture, you address the memory wall. From there, you identify how the attention transformer deep neural networks computations are going on, how much workload in memory. In the distributed computing point of view, how do you do parallel training? When you do parallel training, what kind of workflows, what kind of frameworks, what kind of APIs basically we use. All these things are basically integration is a major work. That's what they call software stack, which takes more time actually. Now means you require many things. One is frameworks, interoperability of the applications, and you require the mathematical model. You require the communication library for the computer vision application, communication library for the teletraffic application, and communication library for the large weather simulation data. All these things you require. At the same time, you also do the in the deep neural networks, you do forward propagation, back propagation, weights update, and then you require the all-to-all communication. How do you address actually all these things actually? So most important is uh, when you do training in the distributed computing fashion, when you use mixed precision, 8-bit, 16-bit, then you don't want to lose the accuracy on the model. Then how do you address this thing? So all these are basically algorithms which we need to develop, especially in the case of computer vision applications, how the classification is being handled in distributed computing, how the feature extraction is handled in the distributed computing framework of the deep learning. These also we need to address actually. So most of the HPC distributed computing now we have been integrated with the machine learning, deep learning, and making distributed training much faster actually. That is what the challenge is there in the today. Now we have the another area which we have is that we have the compilers. The compilers also has to be very good to handle the mixed precision capabilities. That is what the where the algorithm and data and compute is most important for the training, and model size is important. How the compilers are also going to drive. This is also another area which is becoming very popular actually. Now, if you see the overall how the TensorFlow can be integrated with the distributed machine learning framework, and how the communication handle can be done, how the optimization operations can be done, as well as the how the mixed precision 8-bit, 16-bit computation can be done. That is also another area where the we need to focus actually. So if you really see actually application perspective, you have biomedical protein interaction problem is there. You have AI for the telecom, finance data, both are in distributed computing. You also solving special problems. You have the agriculture problems for the AI, and power sector problems, AI for security on one side. All these are come under the distributed computing, and you require scalable analysis. Your aim is to go for the data analytics in all these areas. That means, are you doing data parallelism? Are you doing model parallelism? If data parallelism is done, what kind of frameworks, APIs are there? How do you integrate with the programming framework actually? And if you really see all these things, high level framework, low level framework, and your communication across the nodes, as well as the uh, libraries which are required to scale up on the many of the convolution neural networks simulations. Now, if you see all these things together, one way you have the HPC plus AI, other way you want to do model simulation library drivers, and if you see the AML, you require the supervised learning, unsupervised machine learning, as well as the training time and accuracy, as well as the semi-supervised learning, classification, and application perspective. You have the computer vision application, you have 5G, 6G applications, as well as the uh, neural networks, deep neural networks, convolution neural networks, recurrent neural networks, attention, transformer, transformer workflows, transformer workload, and memory requirements. All these things you need to integrate. It's a big challenge in the coming 3-4 years, and that's what this slide conveys actually. So, lastly, before I close my presentation, from the application perspective, you have scientific applications, you have the enterprise applications, and most of the applications require matrices. In the typical distributed AI applications, you do matrices, you do a lot of matrix operations. Maybe matrices may be dense. In case of telecom traffic, it may be sparse. In case of communication, you have the latency bandwidth. You have the global communication in the distributed AI. IO type means you have heavy amount of IO application may be there, and you have the CPU, GPU is there. Now that means implementation of all applications distributed AI framework or the distributed machine learning with deep learning with large amount of training, it requires pretty good middleware that has to be integrated. So at the end of day, the libraries, high level API, low level API, communication, high level, low level, as well as the convolution neural network, group batch and matrix operations, uh, transformer attention, where the workload and communication time, performance, and you come to the AI side, memory wall, all these things we need to put together for the distributed AI, where the HPC is going to address many of these problems actually. So, I would like to, before I close my presentation, I'll tell you about these are the kind of applications which are there. One is government data, where the blockchain, agriculture, business data, security, teletraffic data, 5G, 6G, social network, digital agriculture. Digital agriculture is another area where you have many sensors, many IoT devices, and you need to optimize the crop growth, optimize the yield, and large scale video processing, and scientific data in physics, and finance modeling, fintech, medical data, protein interactions. All these models require different kind of math model, different kind of training, and different kind of grouped math operations. And some of them we can do using mainly AI. What you require is data plus algorithm plus compute, and this is come under the HPC big data. So HPC big data AI requirements is already hidden actually. So what we really see is that at a high level workflows, high level APIs, and interoperability of APIs, because you have FPGA, you have GPU, you have CPU as the accelerators, and you're integrating all the things. Then how do you handle actually? So that means here, if you really see, training is one, tuning hyperparameters for the billion parameter simulation of the large language models is one, inference is one. All these things we need to address actually. So I would like to stop here. This particular slide gives what are the challenges in the HPCA applications. When you look into the HPCA challenge applications, training is a major component which is there in the bottom, and the framework is there, and all the workflows, high level APIs is one level, distributed computing training is inference is one part, above is applications. That means for every application today, almost all 90% of the application they wanted to explore with the AI. But the math model, as well as the training, as well as the 8-bit, 16-bit GPU, mixed precision computations, all these things are equally important. And simultaneously we need to know more about the how transformer working, how the workload in transformer, how the transformer is taking time, how much time we can reduce on the transformer, where you do 10 billion, 20 billion parameter simulations, and how do you really design the hyper parameters to handle the accuracy and to reduce the time. So these are all the issues in the present era of the AI and HPC side actually. So what I would like to stop here. In brief, I covered an overview. I will definitely share my slides with everybody. I'm really sorry and apologies to all participants that some moral my session today did not go very smoothly, but I tried my best. I'll take a couple of questions because another speaker is also there, no? Dr. Srinivas.
Sir.
Dr.
We should
Tell
say
me, any
apologies,
questions
sir.
are there?
Not you, sir. We should say.
No. See, because There are faculty members, there are young person, they are from industry, they would like to learn a lot of things. Time is very important for everybody. But when we hear the slides,
Yes, sir. Yes, sir.
I will also share my other YouTube lectures if possible. Thank you very much. Any questions are there?
Okay, sir. Thank you, sir. Dear participants, sorry for the interruption. Some issue was happened with the WebEx application. Now it was resolved. Sorry for the interruption and inconvenience to our resource persons and all the eminent participants from all over India. Extremely sorry. And if we have any queries, please ask now. And it is a very
Open
wonderful
for
session.
questions.
Yes, sir. No more questions, sir. It is a very wonderful session, sir. Without interruption, we feel that HPC for AA and AA for HPC is a flag host session. Thank you very much for your wonderful session, and your collaboration is we feel very proud and very much experienced to us, sir. Thank you, sir. Thank you very much. All your 2 sessions were successfully completed, and on behalf of this platform, I convey my wholehearted thanks to you as well as Swaroop sir. Swaroop sir has and one more session on last day, and thankful to you as well as Dr. M.H.M. Krishna Prasad sir. Actually, he is also one of the resource persons. Due to his busy schedule, due to new VC appointment to our JNU Kakinada is busy. So he expressed his unavailability for these sessions. That's why we have taken another alternate resource person, some Ashok Mathani from Maharashtra. So that will be take over by Ashok sir. So I am thankful to you, sir. So now you can conclude this session, sir. Thank you, sir. Thank you very much. Now I request respected resource person, Mr. ADM Naidu, is an industry expert. As our sir told, the youngest resource person of our workshop is actually a cloud expert. Naidu sir, please respond.
Can you hear me? Sir, can you hear me? Am I audible?
Hi, Naidu garu.
Hi, very good evening. Thank you,
Okay,
sir. Thank you.
dear
Thank you so
participants.
much.
Okay, I will introduce a brief biography of Mr. Naidu. Mr. Naidu pursued his graduation from our Bono Venkatachalmaya Institute of Technology and Science 10 years back in computer science engineering. He is a very good and responsible alumni for our institute, and he has 10 years of experience in cloud engineering. He participated in several projects related to cloud expertise. He is working at present LTI Mindtree organization, and he has good experience as network admin as for critical river organization also. He is at present his roles and responsibilities are Azure, Cloud Azure, PaaS related ticketing and load balancing, both L2 and L7 aspects, and managing Azure data factory pipeline creating Azure Databricks cluster, taking care of website certification renewals, and is very good at this cloud data processing and cloud expertise, VPN gateway, and Azure storage and public and private accounts. As time is deviated, I request Mr. Naidu to start his presentation and continue the session 6 on accelerating computing with related to our high performance computing and artificial intelligence. Thank you. Thank you, Naidu. Please share your screen and start the presentation.
Thank you, sir. Thank you so much. Good evening, all. Myself, ADM Naidu. I'm just give me a moment. I'm just sharing my screen. Hope you can see my screen, all of you.
Visible, sir. Visible.
Thank
Very
you.
good.
Thank you, sir. Thank you so much. Myself, ADM Naidu. I'm senior cloud engineer as working in LTM Mindtree. I'm happy to have the opportunity to share my experience with you. I'm glad. I'm very happy to say that I'm the one of the. Just a minute. It's not. I'm just happy to say I'm one of the student from the BBC. I have a 9 years of experience in cloud, and my hobbies are like I do participate in startups, and will take care of expos as well as today's section. We are going to take about the how is the cloud works and how cloud working globally, and what is the marketplace of cloud computing, cloud acceleration. We are going to discuss these topics in this section, and I will briefly give one by one like how cloud came into picture and history of cloud, and what are the past services are involved in this cloud as well as well, coming to the cloud. Everyone say cloud, cloud, cloud. Basically, why we have to use a cloud? We have a phones, mobile phones in our handy. We have a laptops in our handy. Uh, these are have a certain limits. Like if you take your mobile, you can store certain limit of 100 GB. If you take your personal hard disk, you can it will be have of max 1 TB or it may be 2 TB. It's like storage has been limited. Like you cannot store unlimited data or you cannot access anywhere in the world. Then you cannot save. Like there will be limitations in the storage weather. So what this opportunity is made is like if you go to this cloud storage, you can save unlimited of data. Either it may be 1 TB, 2 TB. This huge number of data can be stored over the cloud, and it will be accessible over the world. It can be accessible. Like if you take your laptop or PC, it will be accessible within your hand or within your network. But if you take the cloud, it will be accessible over the world. And this cloud is came like a pay as a network. So whatever the charges you will be there, you will be paid for rental. And then so what is cloud? As I said, the cloud is a remote where you can access bunch of data, and in this cloud we can access applications like email and streaming, office and other softwares. And when coming to the like we have n number of cloud partners in the market. Like we have AWS, that is also on cloud platform, and we have a Azure, Microsoft Azure, and we have a GCP where Google will take care of this uh, in-house infra. Basically, these servers will be hosted in somewhere like California, East US. Like in India, we have a 3 regions like Mumbai, Chennai. There will be a scope. From that scope, we'll use to access the data. So infra we will not basically access, but end user will access that particular application, whatever the application they are using on server or storage, that will be accessed. And while coming to the what is cloud computing, uh, basically we'll come to know, like let's say we have a Amazon Big Billion Day sale, or else we have a number of offers which basically give Amazon or Flipkart. They will give 3 days offers. Like in that time, there will be huge traffic will be hitting the servers. What Amazon background will do is they will not buy any servers on-prem. Basically, if you purchase any server, it will cost of 10 to 50 lakhs. It's too much of expensive. For that 3 days of sale, like they can't affect. It's not like one server. They have to spin up multiple servers at the 3 days of time. So what cloud backend will do is during the 3 days of time, the application will have a load balancer backend. So whenever traffic is hitting to that website, or let's say we are in from India. From India, our nearest region scope is Mumbai and Chennai. Our traffic will not go to East US or Germany. So it will route the traffic to our within the boundaries. So the traffic will be load balanced, and automatically in the background there will be VMs are spinned. Like multiple servers will be automatically will be enhanced and created automatically and distributed traffic accordingly, depend upon the reason. Once if someone is hitting the traffic from East US, it will hit the East US only. When someone is getting from the traffic from India, they will hit the India in the nearest scope, whether it is Mumbai, Chennai, where that is there. And okay, as you said, yes, cloud is a mean of accessing server in remote, and it is a based internet computing technology. And we can, these are the following operations that can be used in a cloud. Like we can use storage, as I said earlier. Uh, there will be a storage account for that. I will show you in the end of that how the storage account will be there. And we can take a backups, and we can have a recovery option also. So basically, in live industry, what we'll do is we have a server. Like let's say we are an office. In that office, we have a server, and we have a bulk of data. Let's say some power issue came, or something has happened, or some redundancies happen. Due to that, server hard disk may crash, or we cannot do recovery also. If you want to do recovery, it is a bulk of data, millions of million data will be there. So basically, what we do is we'll take a storage from the account, from the cloud or AWS. We'll sync to server on-prem to cloud, or we'll directly take on cloud account, and we'll bunch that data in the storage. So the data will be saved. Whenever we want to, we can easily access. We have a backup also. We not take care about infra, that Amazon, Microsoft will take care of this maintenance window and all everything. And also we not make any auto patch updates. There is no taking care of infra. That will be very easy. So we can use storage and software as a demands. There is a multiple softwares that we are giving right now, GPO and Salesforce. Different all softwares are spinning the cloud, and we can use for streaming and audio. Like as we know now, today's most of the peoples are watching movies in only in OTT. Most of the people's not going to theaters. Mostly streaming is becoming main platform. If you take Netflix, Hotstar, whatever streaming OTTs are there, they're backend hosted on cloud only. Uh, and then I'm just moving to next slide. Sorry. Okay. And then I can hope you guys are can view my screen, I guess, right? Thank you. when coming to history, basically before coming to cloud, there is a different architecture that basically followed by the classic network. There will be an end user, and here there is a compute network like on-prem and server. And while coming to the history in like 1961, there is a scientist called John who discovered this demand-based applications VMs, and then in the market, 1993, www.com came place where easy to access the websites. Like eBay is the one who came into the market, and 1996 the Salesforce came into the market as a PaaS service, and 2005 Geo where it came for email servicing based. And if you go to 2019, and then Google was came into the picture. In 2009, all market players came into Azure, Oracle, HP. I mean, there's multiple right now. There everyone is coming to the cloud with their own infra plans. Even Geo was trying to have a cloud based in future. Mostly we can expect from Geo also. They are doing some backend work. This was the traditional computing we used to have. Like on-prem, we used to have a server and hard disk and internet. In traditional network, we used to hire a one networking person, and we have to pay a salary for him, and we have to take the AC has to be run continuous 24/7. Power should be consumed, and for the to access this remotely, we used to have a public IPs also. For that also, we have to pay some amount to the ISP providers. Like, and if you're taking the server also, it's too expensive. Let's say in basically in modern days, we'll get a project for 1 month or 3 months, and if we want to buy a server for on-prem, it is so expensive for the company. For a couple of like 3 to 4 months, buying a server is a big impact to them. Its budget will not be allocated from them. So in that space, they're using the cloud. They will spin a VM server as per their demand and applications. They will use it, and for a 3 months or 4 months, they will spin it off. Whatever the 3 months they use it, they have to pay for the amount. That's it. So this made very easy to the cloud, I mean IT sector. And after COVID, it has a huge demand in the market of cloud place. This is the traditional, and here is the application like infra, storage, runtime, and the server application internet. This whole will take care of the marketplace. I mean, we do not take care of this maintenance. That they will do the backend team. They will give the storage account. They will provide the security also, and application that depend upon the time will spin it and will end it to the application. So this made very easy to the IT team. And top benefits of cloud computing. So we can discuss here like cost saving. As I said, if I want to purchase server, it will be cost too much. So if I take a VM in a cloud, it will cost me like for 1 month, it will cost me 5,000 or 7,000, depending upon the server expenses. And also feasibility. I can access anywhere in the world. It's not like I can access only from my office premises. It's not like that. You can access from anywhere in the world. So there will be public IP for that allocated, and you can access anywhere in the world. And also it will be available by 24/7. Basically, when we go for a core networking in earlier days, we should have some maintenance window where users are not working. Like Saturday and Sunday, we used to have some maintenance window. In that window, they used to do some patchings, applications, OS patching, and all everything. Now, these patching will not work with there. This taking care of our cloud. And reliability and scalability, unlimited storage. As I said earlier, um, I came across like when we purchase a server with a 1 TB, 2 TB, depend on the project use. Again, we used to buy one more extra hard disk, and we have to make a external, and we have to boot something. It will be for implementing a external hard disk. It will take for 2 to 3 days. We want to if you want to implement. In a cloud, it is very easy. It will be like 5 to 10 minutes. If you want to increase the space, we can immediately increase as per our requirements. That is also. And cost saving, yes, it is a cost saving. And easy to backup and restore. Yes, we can make a restore point and easy to access. Automatic software updates, yes. The team will be there and they will push the backend applications. Performance wise also it's perfect. There will not be any delay in the loading the applications, and there will be a lot of difference in loading the applications when you take a on-prem server and a cloud server. The reliability and accessibility feasibility are top notch. So it's like a boom, like that traffic will hit the end user very fastly. Uh, then we can discuss the examples of cloud computing. We have a multiple partners in the cloud. We can see Office 365, where we use emails for our organizations, and AWS, that is also Salesforce, and Google Drive, Geo. Geo is a email service which was based by Tamil Nadu. So here are the emails. Basically, we use emails for the communications one-on-one. For that, we purchase a domain. Like if you want to take like bvc.com, it's a domain. From the backend, we take from emails from Zoho or Office 365. They will give the per user. There will be some cost should be charged from the user. On that, that will be services are provided by the cloud computing. With that, if you take a Office 365, we get a email, OneDrive, and also Office 365 suite will be freely given by the few members who are taken as a membership. If you want to buy a purchase Office 365 license for MS Word, MS Excel, it is purchased for the license. If you take a Office 365 emails, by default, the feature will be given as add-on for the organization's levels. That was the one of the feature where Office like Microsoft is giving. If you, I mean, like it's like a add-on for the organization. They do not to buy any licensing for Office 365. It's came up by the default. And also OS license also will be given by default Office, like that. So Jaho, Jaho also one of the fast growing company as well as Office 365 email servers. And like as a cloud, we do have a pros and cons. Like every will be have advantages and disadvantages. Pros like advantage like we can reduce the hardware equipment for end user. Like we don't want to buy individual parts for that server, and implementation performance, low maintenance, instead software updates. Instantly we can get the updates from the server. Whenever you're giving an updates to the server, it will automatically take the backends pool and it will revert the applications for the front end. And implement for disaster recovery, and we have the backup plan will be there. If you are taking with the license, you will get a backup also. There will not be like 100% whatever the data is there in the storage, it like a 100% safe. Like you don't lose the data at any cost. If you lose the data by any chance also, team will be there, Microsoft team will be there, we can raise a ticket with them and they will do the recovery also. For that some redemption time will be there. Within that only we have to lodge a complaint. Like when you go for a disadvantage, not much. Like we don't have the controller and infra. So let's say you take a VM or server or storage, we don't have access to the infra level. So basically here the team and they will be managed, like we don't have the control on that. And whenever we are trying to access these applications, we should have a good internet speed. Until unless you should, I mean, like there will be MBBS, KBBS dedicated to this accessing this cloud based applications. It should be like bandwidth should be good. If your bandwidth is poor, you are unable to connect to the cloud applications. It will give a timeout error or it will spin out an error. It won't allow you to go for further. So always you should have a good bandwidth, and high speed internet should be mandatory. And also this cloud will give the public IPs for the end users. Basically, we buy public IPs from the ISP provider. Here they will give the IPs for the applications that will taken care. Basically, this is the architecture of cloud. Meantime, I will, for a change, or I will drive you guys to my Microsoft application, and I will show you how this VM will be there, or how storage will be there. Just a minute. Basically, this is my Microsoft account. Everyone can have this account. We have to just register, and you can see the bills that are used. Very nominal, like 40 rupees, 60 rupees. Somewhere I do in my lab, it was cost me for like 1,000 rupees. So whenever I require something, I will spin up, and we can delete it. So whatever the amount you are there, it will be charged for you. And this is the Microsoft Azure account. AWS also will have the account. That is a different one. So here we can go all the services. If you can see here, I will show you. These are the all services which is giving. For AI learning, we have the AI research, good service. And if you come to the analytics, we have the data factory, data lake, data engineering, data clusters. And if you come to the compute category, computing, we can take a like VMs and web app, function apps, container. Like this is also clusters, and we can use here the containers also, and we can use database if you want
Sir,
to run
sorry
any.
to interrupt you. Sir, your voice, your screen is not visible, sir.
I'm so sorry.
Yeah, we are
So
getting
sorry.
a white screen only.
Oh, I'm sorry. Is it now?
Yes. Visible.
Sorry. Yeah, thank
Sir,
you.
it's visible now.
Okay, thank you. This is the Microsoft account that basically we do. Here we can spin whatever SQLDB, cloud computing, any VM, server, storage, whatever you want, we can spin it here within of 5 to 10 minutes only. And I will show you the bills that basically I do when I get some time. Here you can go to invoice. This is the bills that I was showing before you. I use it for some cloud computing. It's charged only 40 rupees for me, and here it's charged only 6 rupees. I just pin some VM, I think. Somewhere it charged me, it's 1,000 rupees. I think it's application gateway that we tested from our end. Like here, charges are very minimal. If you take a, I mean, if you think about end user, like we are normal user. If you want to buy any laptop, it will charge you right now as per normal laptop only it's charging 80,000 something. If I take a VM here, it will charge me per 1 hour, it will charge me like 100 rupees or something. Like if you think about that organization level, it is very cheap to them. Like As they're getting the business, they can run these applications or they can afford this, what are the charge they are giving by the Microsoft. They can run huge number of VMs. If you take our organization in VMs only, we have around 10,000 VMs are using. Let's say how 10,000, like it's like they are paying huge. We cannot unbelievable. Only for VMs only 10,000 we are using, like storage and applications, load balancer, L7, L2, Azure front door. Like it's a bulk. It's like we can't imagine the cost also. Some companies will pay crores for the cloud management, crores, like 2 crores, 10 crores, like depend on the manageable scale, they pay like that. As they're having a running business, they can afford. Okay, and I will show you what are the services they are giving. Here, Microsoft came like AI. If you want to spin any AI related Azure AI services are there, boot services, documentation, and API face. You know, so many applications are getting by face APIs. With that, you can explore. And also speech service. When our application will do Hey Siri and like that, we'll do like how we will test. We can test it here. And for analytics, we have a number of analytics, data factory, and Power BI, Azure Databricks. And while coming to the computing, VMs will be there. Here you can use virtual machines and Azure virtual desktops. Images will be there. Depend upon the user, depend upon application will do this implementation. Basically, when we are installing an applications in a locally, we use NPI, Apache, Tomcat, and we'll do test in the locally. Here we can test within the VM. That applications can be run within very few seconds. We can as a publicly. If you want to make an application live, it is like a huge process. You have to take a server. In that server, you have to write a DB. In the DB, you have to make the queries. In queries, we have to give a public IP. Like it's like charging. So here within the short time, we can spin it and we can be given a public IP. If time allows, I will show you that also. And we have the containers, different based upon services. We use this database, DevOps, and like storage. We have security, like different n number of services are there right in the application. We'll have one DNS zone, pattern will be there, and migrations. I will try to spin one VM and let's showcase you how it will be there. See, within 5 to 10 minutes, you can spin the VM. I will show you. We will take a Azure VM. We'll take the resource group, VM name. Here we can select the region. If whatever the nearest region we'll take. If someone is using this application, if someone is trying to regions application, we use the East US, or we'll use East West. I mean, depend upon the region they can use. If you are from the India, like we have these like South India is there and Central India will be there. Basically, when you're spinning the VMs, East US will be the cheaper. For that, I will take East US. We can give the availability zone. How many zones you require? And here we can select the image, which image you want. You want Windows or you want Windows Ubuntu. Let's say there is a different requirement. Someone will ask that Red Hat required. Windows Server Data Center. We'll have a number of images. Server here we can have the marketplace. We can select what are the OS flavor you require. Windows Server, Windows 11, or Ubuntu, Red Hat, multi, Ubuntu like CentOS. We can use a CentOS. Like we can have, and marketplace will be there. And depend upon the requirement, we can select. I'm just selecting for time being Windows 10. Like size. Basically, here we can select the how much size basically required. Depend upon size, we'll access this. Standard 1 GPU, 4 GPU, 16 GB, and 2 CPUs, 16 GB, like that. Depend upon the flow. I mean, you can see a number of options are there here. How much RAM you require, how much data space you require, and general purpose. If you want to go for any high end, we'll come up with, then sometimes we'll have the requirement like that. I need some huge space of high speed, high performance of VM. In that time, we can go for E server V6, different like that. For timing, I will go for some normal option, and we can give name. And we can give the what are the ports should be allowed. Let's say your application has to run in HTTP, we can give a port 80. If you want application should be run in HTTPS, we can give 443. Or you want to access your VM only SSH. SSH comes when you are accessing Linux or Ubuntu server. We do take care of SSH. As we are connecting Windows, we can go for RDP. See here, we can give the license also. I confirm eligible for licensing for Windows, or it's like automatic license. Basically, if you want to take a license only, it will cost 15 to 20 bucks, 15 to 20K, depend upon the license versions they are. Okay, I'm just here we can see the cost, estimated cost also it coming. It's cost of VM, and I selected the little higher version. This is D2 to V2. It's costing 8,000, and it's costing the disk OS network management, and it's showing me 10,000 for the month. If I take for 1 hour, it won't charge that much. Like affecting a 10,000 for IT based companies who are a good rotation business, that doesn't matter. For it go for one hiring, one resource only it will come. And also, if once project has been completed, they will delay it. So it's like a cost cutting only. Select import HTTP. Here we can select, like in that hard disk also we have a SSD. You want SSD or standard or HDD, premium SD. If you want to have some speed of, we'll say we take when we take in hard disk also we have a HD, SSD, like that. We'll have the versions also here. Here we can attach any hard disk. Like if you have any existing space here, we can attach here. If you have any external storage account, we can attach here, like plug and play. You can depend upon the requirement, you can plug it here. Once you're done, you can unplug. Like it's like a drop and go. And there will be one IP will be assigned to this. This is the private IP, and one public IP will be assigned to this. And also we can do the load balancing also. If you have a bulk of traffic, as I said earlier, when the traffic is used, we can use the load balancer and application for that. I mean, we can use application load balancer also. There will in load balancer, basically we have a L2 and L7. So this load balancer will come on L2. L7 is application gateway load balancer. And I'm going for the management. These are the basic details. It's asking identity. This is the AD part. do you need any auto shutdown? We'll say for the cost cutting, let's say I'm in Indian time zone, like after 10 to morning 5, I don't use this VM. During that time, we can have an auto shutdown. So when the VM is running only, the cost will be generated. When it is having a shutdown mode, like cost will be generated, but very less, very minimal will be there. It's asking for auto update here. You can give, if you want to give manual update, you have to update manually. If you select auto updates, yes, it will go for auto update. Boot diagnostics, this will be used for the health. For diagnosing, if you enable this option, we can troubleshoot when we have any VM. This will be custom, and tags we can give, or else we can review and create. So, okay, these are the details of premium Montreal. Okay. Within like short time, this VM will be spinned and it will be accessible. Basically, in classic, in a traditional network, we'll order a server and we have to do the payment. And one invoice is raised from the company side. We have to update that invoice to Dell or whatever the market partner. For invoice application, it will take 10 days. And for delivery, it will take 10 days. And once you got that server for building in a rack or tower, it will take 2 to 3 days. And after installation the on a rack, once you mount that server, again we have to give the power supplies, and voice should be installed, and AC. Like there are multiple things are involved in the if you want to build a server. Now it's like a very easy plug and play. I'm sitting here and I'm spinning in the VM. So this made productivity increase and reliable. Like it's like plug and play. Like it's very easy. It's become very easy for the tech guys. So the VM will be spin. Then I will show you how it will be charged. These are the POP servers basically located. If you go to this image backend, this is the where servers are built in the all over the globe. Sorry, this is the POP servers. Like basically we call this as a POP servers, like WAN centralized WAN we call, and across it there 61 regions it is there, and we have a both global network capacity. So these are the graph of POP servers, and it's are interlinked by each and every one. If anything happened in the East US, it automatically have a replica in East US or in Germany. If any, let's say we are in India we have a 3 POP servers. If when go to the back, we have a POP server in Chennai. During that time, there is a floods has been came in Chennai. During that time, there is a impacted infra. At that time, automatically it has been made a replica to the Bombay POP server. Like that, there will be replica, and there will be always a backup. So POP server in Chennai, when due to some reasons it's unable to reach, but at that time productivity has gone. Like it's not impacted any business cycle. So it has a more relay on the flow. This is the document. Okay, I'm coming back to here. Yeah, see, you can see, like I don't, for us installing VM, it don't make me take at least 5 minutes of time. I think its VM has been spinned. We can connect it here. Here, once the VM has been connected, we will get one public IP. From this public IP, we can access. I will show you if I can access. this is the public IP. Like if sometimes what will happen is when end user is connecting with the public IP, sometimes this IP may change. For that, we can use any name and then we can save this. For this, DNS record will be generated, and with this DNS name also we can access this VM. Let me try to connect if I can do. This is the public IP. Let me try to connect to the server. Hope my screen is visible, right? Are you able to see RDP connection that I was in the screen? Yeah, thank you. So I'm entering my username and password that which I given. Naidu. It will ask for the certificate. See, I'm just loading the server. Hope you can see the screen, right? It will take few minutes. If you have any queries, let me know. Meantime, if it is loading, I'm happy to assist. Once it loads, I will show the how will be normally it's there. See, here I'm accepting the license and done. See, it is connecting with the public, like anywhere I can access. So this is the server, like normal how we have the laptop, it came. All the services are available. Like internet will coming to this VM, and you can browse anything here. Yeah, internet is also coming to my server. Like this made very easy for spinning a server. Okay, I'm just coming back to the PPTs, and let me know if you have any queries in this part. Like I can, like, if any, let me know if you have any queries. Okay. Okay, this is for the architecture that we have a front end, and we completed this. This is the architecture of backend. We'll have the monitor for. We'll have the large number of data stored in the backend, and we'll have the details like applications managed and security and server and the services is the back end and front end. And we'll come into the cloud deployment. We do have the we can access cloud in a 3 different ways, like public, how we do this VM. We done this VM server hosted publicly, means there will be public IP send. We can access privately also. There will be on-prem to cloud will be there. For that, we have to use a VPN or anything to connect it. Like hybrid, we can use both public and private for connecting the applications. Well, coming to the public mode, we have the Salesforce, AWS, and Microsoft. These are all mode of connected by entities are cloud-based, and by the hosted in the customers easy to access these applications. It is a formal, it's hosted on cloud. It's hosted on cloud-based, and will be supplied by the different suppliers in the entity in the market. We have multiple like GCP also comes under this, and this is for the private. In on-prem, basically we just have a server here, and we can connect only within the network. If you want to connect to the private network, you should be the part of the internal only. Okay. And for the contending, it's not available for the public and the single organized entity, and it is managed by the internally by the internal and third party. We can host internal and externally. There is a slight difference between the private and public in the handling the hardware. And this is the hybrid. You can see this would be like you can access both. Like you can be accessed via hybrid and publicly. We can let's say we have a server in the on-prem, and you have a services in the cloud. We can access both by establishing the bridge connection between the two entities. Basically, from this architecture, the security will be flown, the traffic will be flown to end via VPN certificates base. And in cloud, will come, as you know, I said before, it's a pay as you go service. It's a pay as you go service. So like how much you are using, like if you're using for the 1 hour, you can pay for 1 hour. If you're using for the 3 hours, you can use for 3 hours. Like it's like a rental based, depend upon the purchase and maintenance, cost will be charged. And in cloud, we have a 3 modules, maybe you were aware, like a as and PaaS and SaaS. These are the most commonly offered by the computing cloud platforms. SaaS is like infrastructure, like VMs are hosted in the cloud, like server, like we have a POP server in the particular region. That will come Azure services and AWS services are comes in the infra as a service, because there will be infra in the base location from that VM that hosted somewhere, and that space we are using this cloud. Either will be backend or a front end. Application will run on that place. And well, coming to the PaaS, it's a platform as a service. It deployed only applications based. When there's come a SaaS, is like a software as a service. Like we can say Office 365 or Salesforce, all this comes under a SaaS service. Yeah, here we can see infra as a service. Like we can come AWS, Microsoft will come under this infra as a service. It's on-demand cloud hosting platform networks where server storage and network resource are customer can be provisioned. Like we will be the provisioning these details, like what are the network details we are giving, configurations are giving. That basically we have the more control on the spinning. Depend upon the requirement, we can disable the public access to the application, either you can give the private access to the applications hardware. The difference is that cloud platform host, manager, maintain hardware and their own data center. Like they will have the own data center, and we will not see physically. We and users will see the only GUI of the front end application. Like I have showed the Azure portal, like that only we can see the application. We cannot see the backend what happening, or how the storage is spinning. That we cannot see. We can spin what are the applications we can, and we can go for a pay as you go. And benefits of as like high availability and low latency. Also, like if you are belongs to the particular region, you can spin within the east US or geolocations only. Like so, there will be less latency. If you're sitting in India and you are selecting the region like east US or Germany, the latency will be high. So to reduce the latency, only use the within the region, and implement the process, and component security and fast and accessible, easy to accessible. Like how we do this. This is the traditional architecture. Like we have the data center, servers will be there, network and will be there, virtualization. By combining all these skills, we are using a SaaS service like AWS. Other cloud platforms like Oracle comes under as service only. And we're coming to the PaaS. PaaS is like a platform as a service. We can use for DevOps team, like how DevOps is work like is the PaaS services. It will be included cloud integration, testing, delivery, and network-based runtime. What are the software and database is given by the PaaS team? We can have the fast time markets, same similar as the all. Like we do distribute like PaaS, SaaS, and services on that depend upon the availability. Like here I can show you. This is the PaaS structure. We can have the platform, and we'll have the software on that, and developer can test their code, and then they give this the market. Like it's like plug and play. So and last we have a SaaS. Basically, this SaaS is the will become under the Salesforce, like iCloud, Dropbox. Like mostly it's like a storage based applications will have the backend. The risk will be minimum, and access by anywhere, anytime, and easy to productivity. And for this, we'll have the vendor management. Like for the Salesforce, we do have the vendor management for patching, and very less SLA. Applications are low based applications also runs very easily in this platform. This is the classic of architecture. How we can use email marketing, analytics, invoice applications, help desk, but like depend upon the application we can add on. Like some users will ask that we need for the website we need live chat, or for application we need the voice calling or invoice generating. For ERP also can be used. Basically few HR applications will be enhanced in this SaaS service. This is the uh, like how this architecture will be there. For on-prem, we will have the basically network and storage, server, virtualization, OS, middleware like runtime and data applications. These are the architecture of modules for the on-prem as well as infra. Well, coming to this, like Microsoft Azure, I can give some more inputs. Microsoft Cloud Computing offers various services like storage, networking, and it helps the business scale applications and runtime in the cloud. It's have a continuity business, like 24/7 it's available and feasible. And Azure is a flexible cloud computing. It enables the quick build and deploy management application across the global network. Manage the data centers, like manage the data centers in the sense like whenever you are spinning an application, it will be automatically replicated all over the data centers. You can build this application using languages. What are the languages you prefer? You can deploy applications in Python or framework. What are the framework you can use? You can use in this language, depend upon the marketplace. Key takes like Azure, Microsoft Cloud having more than 200 product services are available. Yeah. In the service, you can have around 200 products are available, like cloud, VMs, storage, AKS clusters, data factory, AML tool, Copilot, like that. We have around 200 products are available in the Microsoft Azure, and more than 300 high server data centers around the 60 regions. Like they have the footprints, as I shown in the earlier picture, and also 95% of a Fortune 500 companies trust the Microsoft for their business meet enterprise scale demand. Most of the MNCs companies are using this Microsoft Azure. Why? Because as we are using a Windows OS like Microsoft Windows 10 or 7, so when these applications like companies or MNCs are using this Windows based laptops, it is very easy to access the Microsoft Cloud applications. Like we don't have any uh, boundaries for connecting the applications. While AWS also used when they are using the Linux based VMs or Linux based architecture, most of the companies go for AWS. When Windows based, most of the companies are using Azure. Like they can get the email, Office 365 will be there, and in that one portal, like there is a one portal is enough to manage all accesses. Like emails you can access, and Office 365 suite you can access, and Microsoft Azure, emails, domains, everything come under one roof. Like bunch of products are available in the Azure. So with one portal, one click, we can access all these services. So most of the companies are using Microsoft Azure only for this extra benefit and easy to access. Like we not need to train anyone guy how to use this Windows laptop or this application. Whereas if you want to train or if you want to use your own Linux or Windows application server, we have to train them or we have to give some efforts to learn. Like it's Windows is easy to access, user based OS where it's come. So most companies are going. I mean, it's using the Windows only. And all business sizes are using helping to bring the seamlessly united technology and innovators trust. And okay, while coming to the as we discussed, as I showed in the virtual mission, um, you can use this size space. It's a VD hard disk, like hard disk, like virtual hard disk. Basically, in traditional, we have to purchase a hard disk accordingly. If we end up with the 50 GB, again we have to buy for the 1 TB or something. Like here, we not buy an external, like it's plug and play. You can give the hard disk space how much you want. You can give the 1 TB, 1 GB as per your requirement, and you can spin it off. Like it's a virtual hard disk. Both in the Linux also it available, and website you can use Azure platform for creating the hosting the website and web applications. Yes, we can not only install applications in VM only not. There is a in Microsoft Azure we have a service called Web App where we do not require any voice-based VM. Like I showed you, I connected with the virtual machine. It's not right. It's not required. Without VM or server also, we can spin the application and we can host mobile services like tools will be there. You can create Android OS applications or Java, JavaScript, Windows based, and we can use for the supporting operations, programming language framework tools, database, Java, .NET, PHP, whatever runtime you want to spin the website, you can go as per the requirements. It's not like that you have to use PHP or Node.js. We have multiple runtimes are available in the cloud. You can use as per your trust and requirements. As its conclusion, like cloud computing has a quick become the one of the most priority buzzword for the IT due to this mode of communicating, and it promises the increasing the feasible scalability and while it's reduced the operational cost support. When coming to this operational, like we should have a separate team for this operational monitoring, and also it's become the costless. It reduces the cost also for the companies. Depend upon the project only they can go. Once the project ends, they will wind up this applications. And also it will not hamper the growth and the idea to handle the implement data to another company vice versa. If company A has the storage account and company B want to access, it can be accessed. It's not like that we have to do a peering to the subscription. Subscription A to B, we can do the peering. Different account to accounts, we can do the peering. And Azure to AWS, we can do the peering. And we can exchange the data across the organization without any data breach. That is one of the feature that what cloud is providing as of now. That's it from my end. If we have any questions on this, let me know.
Dear friends, thank you very much for patient listening. If you have any doubts regarding this cloud computing as an accelerated computing for our high performance with respect to AI flavor, basically the cloud performance cloud operation involves high performance computation capabilities. That's why this session was included. The audience can post any questions or directly ask our person ADM idea. Naidu, very much. Thank you very much.
Thank you, sir. Thank you.
For session on this ATAL FTP, it is the AICTE national level FTP. Your participation is very much appreciable. Thank you very much for your smooth
Thank you, sir. Thank
presentation
you.
on cloud computing. And we'll wait a few seconds for anyone is asking queries.
Yeah, sure, sir. Sure, sir.
VC Rao, sir. Good night, sir. Good night, sir. Okay. Yes, sir. Thank you, sir. Thank you. On behalf of my department of Computer Science Engineering, Monu Venkat Chalme Institute of Technology and Science, the third day FDP on high performance computing using AI. Sessions were successfully completed. Thank you very much for all the participants and resource persons, Mr. Naidu and VCV sir. VCV Rao sir, till sir is online and patiently listening and guiding us. Thank you, sir. Thank you very much. And all the participants log off and thank you. And tomorrow we have good sessions by Usha Devi madam from JNTUK. Already first session was conducted. CUDA programming session was conducted and hands-on session. And Mr. Venkata Gurram from VSC resource person, he will give AI tools and parallel processing and parallel programming for AI concepts will be demonstrated for us. Okay, thank you very much. Good night, all of you. Thank you, sir. Thank you very much.
Thank you. Thank you all. Bye.
Link, feedback link. వచ్చేసిందా? రెండు 2015 వరకు పెట్టాం కాబట్టి